Hi, welcome to another edition of Fun with Conceptual Physics, the projectile motion edition. These problems, I believe, are all horizontal problems. What that means is an object is thrown with a horizontal velocity and it goes to the ground like you're standing on a bridge and throw something straight out. So let's look at this problem. Take a second, and I'm assuming you've read this problem. Immediately, my eyes go to this statement, and I'm going to circle it. 80 meters high. That has to be what I call my distance in the y direction. This here is another distance. There's only two distances to worry about. Once you have identified what dy is, the other distance has to be dx. What do I mean by that? If I draw this, I'm standing on a balcony, somebody's standing on a balcony, and they're going to throw something off. When it says high, this has to be my dy. That object's going to be thrown out horizontally with some horizontal velocity. And that object's going to go in a parabolic trajectory. So the path is a parabola. That's the name of the path. Something you need to know. Well, this distance here has to be the x distance, or what we want to call the range. To do this problem, they wonder how fast. Underline that, how fast means they want to find their x velocity. To do that, we have two formulas we have to know. We have to know that dx equals vx times time, or another version of this is one formula, vx equals dx divided by time. Well, since we want to find our x velocity, and let me label that on the problem, what velocity we threw it with, this is the same equation, just rearranged. The other equation is time in the air. Time in the air is the square root of dy divided by 5. Now you're going to have to divide, then square root. So those two equations will be used for every one of these problems. Remember, this is the same equation, just rearranged. Well, I know my dy, so my time in the air will simply be 80 divided by 5 and the square root of it. So at this point, I'm hoping you have a calculator, because you would have had to get a calculator for this. And in my calculator, try to take the glare out, I'm going to take 80 and divide by 5 first. That is 16. That is a nice number. Now I want to take the square root of that. Another way to do this is do second square root, second square root. Get the square root symbol up there. Notice the parenthesis. Put 80 divided by 5 and close the parentheses. If you do not close the parenthesis, you'll not get the right answer. You can try it on your own, but this is the correct answer. 4. It took 4 seconds for this stone to reach, or whatever they threw, to reach the pool, because you were 80 meters high. That distance, it took 4 seconds for this object to reach the pool. This distance really determines how long it takes to hit the ground. because dy is what I have control of, what height I throw from. So now that I have my 4 seconds, I know my delta x is 30. My x velocity is going to be 30 meters divided by 4 seconds. And if I do that and hit clear, 30 divided by 4, I'm going to get 7.5 meters per second. So now you have enough information. Put your first and last name on this paper. This paper is due at the end of the hour. Or actually, you're going to have less than an hour because you also have book problems today that we're going to talk about. To do these problems, the very first thing I did was, I have these formulas, but identified what was given to me in a problem. In this problem, it says tall. Tall is another indicator that this is dy. This says horizontal distance. It literally screams dx. This is horizontal, so this direction is horizontal. This direction is vertical. I'll pause for a second. So, going back to the problem, I've identified those two things. And again, they want speed, so obviously they want Vx. Going to the next problem. Here, they're going to give you your Vx because they say speed. So that is your x velocity. Here, it says overhead. This clearly has to be your dy. Whenever you have your dy, you can quickly get your time in the air. And I'll come back up here and put a little a on this. These are times in the air. I omitted to do that even though I did it over here. So I put an a here and a here, just remind me time in the air. In this problem, you know Vx, and you have time in the air, and you want horizontal distance. You want dx. Uh-oh. That means I've got to use this version of the formula down there. So if you can very quickly write that formula down here on problem 3, you can write the formula in problem 3 right there on your own. I'll pause for a second. So, the following problem, and you could do these on your own. Here you're given meters per second. Meters per second is not a distance. Please understand, meters per second means velocity. That must be my Vx. Obviously, 4 seconds later has to be my time in the air. And all they want is horizontal distance, so they want dx. So once again, you'd probably use the formula, same version used in problem 3. So there you have it. When writing all your answers, write your answers with units. For instance, the units of dx better be something with meters. When you solve for Vx, something in meters per second. Put units on all your answers. Notice I did. This is due in a short bit, and you do have book problems you need to work on, and they will also be required. And if you don't finish the book problems today, you'll have them to do tomorrow.